Hi everyone, welcome back to my channel. So last two video we are discussed 20 question regarding three-phase induction motor. Today we have to discuss another 10 question regarding three-phase induction motor. So what the 21st question is, what is in an induction motor 5% change in supply voltage will cause rotor torque variation of above. So this is a question regarding and the relation between torque and supply voltage. So when you are increasing, when you are changing the supply voltage, what will be effect on the torque? So option A 2.5 percentage, option B 5.5 percentage, option C 10 percentage, and option D 125 percentage. So we can go through the analysis. Okay. So there is a relation, you can see that the effect of change in supply voltage on starting dot TST K1 into E2 square into R2 divided by R2 square plus X2 square. Okay. So there is a equation. Okay. This is a equation in the three-phase induction motor. Here you can easily understand that E2 means the rotor EMF. E2 will be directly proportional to the supply voltage. So starting torque will be K3 V square R2 divided by R2 square plus X2 square. So it is a R2 square plus X2 square is a Z2 square. So it will be K3 into V square divided into R2 divided by Z2 square. So TST will be directly proportional to the voltage square. So supply voltage. So there is a relation, there is an equation you can, when you are studying three-phase induction motor, you can see this equation. Okay. So means we want to equation like that. The T starting torque is directly proportional to the voltage square. Okay. So first condition you can take T1. T1 means the first condition torque, it is directly proportional to V square. The second condition T2 is directly proportional to the 5% increasing voltage. So we become 1.5% matlab 0.05. So increase will be 1.05 V square. So पहले V है. The next condition it will be 5% increase, that will be 1.5% matlab 0.05. So it will become 1.05 into V. Okay, into whole square. That is a directly per square. So when you are 1.05 square, what is 1.10? So T2 is directly proportional to 1.10 V square. So when you are taking the ratio T1 by T2, T1 divided by T2 is equal to V square divided by 1.10 V square. So V square cancel. So T2 you can change to here. So T2 proportional to the T1 into 1.10. T1 into 1.10. So actually it is a T1. But in the second condition, when you're increasing the 5%, it will be 1.10. So here is 0.10. Matlab it is a 10%. So increase 10% of torque. So second time torque will be 10% increasing the first torque. So 1.10 into T1. So our answer will be 10%. So only the important relation is the starting torque is directly proportional to the supply voltage square. Okay. So when you're like that 5%, 10%, 20%, like question will be coming. Okay. So when the supply voltage is increases by 10%, what will be changing in the torque, starting torque? Or otherwise, when the supply voltage is decreased by the 20%, what will be the starting torque? So you can find easily by using this equation. T first condition you can take as a V square. Second time, what is the increasing? Here is a 5%. I am taking 1.0. If it is a 10%, it is a 1.10. Okay. If it is 20%, it will become 1.20 into V the whole square. Okay. So it is a answer. It is a 1.10. So it will be 10% increase. Okay. So next condition, starting torque of an induction motor is proportional to, starting torque and induction motor is proportional to the supply voltage, half of supply voltage, square of supply voltage. So it is the same as the previous one. Okay. So starting torque is directly proportional to the V square. That is directly proportional to the supply voltage the whole square. It's an important question in most of the multiple choice exam, MCQ exam, multiple choice question exam or competition exam. This question you can see. Okay, so answer is our C is the answer. And next question, when the supply to an induction motor is switched in the beginning. Okay, so when the supply to an induction motor is switched in the beginning, the induced EMF in the rotor. So uh, the induced, you have to find what is the induced EMF when the motor is starting. So when the supply is, so when the motor is starting, switched on, that time what will be rotor induced EMF? That is the question. The EMF in the rotor will be. Okay, once more. When the supply to an induction motor is switched in, okay, in the beginning, the induced EMF in the rotor will be. So when the motor is starting time, what will be the rotor induced EMF? It is a 0, maximum, minimum, same. That will be four option. So we can go through the analysis. So you know that the rotor EMF will be is equal to slip into rotor EMF at the starting condition. Okay, so rotor EMF ER matlab rotor EMF in the running condition is equal to slip into the rotor EMF in the starting condition. Okay, so that is the one equation is there. When the motor is start to rotate, so when means the when the supply is switched on, so what is the time? That is a n is 0, so slip will be equal to 1. Okay, starting time, you know that the slip will be equal to 1 and it is going to decrease. So when the starting time slip is 1 and when the running time it will be decrease value. So at the starting time slip is maximum, so the EMF will be in the maximum. Okay, so ER is equal to S into E2. When the starting time S is equal to 1, ER and E2 will be same. When the running condition S will be low value, so below 1, so ER will be decrease. Okay, so EMF in the rotor will be maximum when the starting condition. So our answer is B, option B. So when the starting condition, the induced EMF in the rotor will be maximum because ER is equal to S into E2. So slip is a maximum value at the starting condition. So the induced EMF will be also maximum. So then we are going to the 24th question. Okay. So what is the 24th question? Speed variation of squirrel cage induction motor are essentially similar to those of. So there is a four motor is there. One is a universal motor, other one is synchronous motor, and the third one is option C is DC series motor, and option D is DC shunt motor. So squirrel cage induction motor, you know that you already discussed that when the load is increasing, what will happen? The speed is varying very slightly. Okay, there is a slight variation is there. It's not a constant. Okay, so there is a four option that we can discuss also. First one is universal motor. Okay, so what is a universal motor? There is a, you can see in our home there is a familiar one. It is a using the mixer that we are using the universal motor. So universal word means you can work with both AC and DC. You can give the AC supply, you can give the DC supply, the universal motor will work. And other one is synchronous motor. Okay, what is synchronous motor? So synchronous motor is a motor is rotating in a synchronous speed. What is a synchronous speed? It is the speed of the magnetic flux. That is a constant. So when you're giving the one supply, the synchronous speed will be constant. So when any motor is run at a synchronous speed, that is motor is known as a synchronous motor. So it is a constant speed motor. Okay. So DC series motor, in the DC series motor, when the speed changes when the load, so when the load is changing, the speed of the DC series motor change very, not a slight variation, a big change will be there. Next was in DC shunt motor. Speed change is very low when the load changes. So that is a DC shunt motor is very familiar with the squirrel cage induction motor. So there is a speed change will be there. Normally DC shunt motor it is known as a constant speed motor, but is when the load is increasing, normally some slight variation will be there. Okay, so same in the DC squirrel cage induction motor. So speed variation squirrel cage induction motor is almost similar with the DC shunt motor. Option E, option D. Okay. So 25th question. The slip of an induction motor is the ratio. A is stator copper loss divided by stator input, rotor copper loss divided by rotor input, rotor copper loss divided by stator input, rotor copper loss divided by rotor output. So it is a equation. It is a question. You can easily find the answer using the power flow diagram that already we discussed. So in the power flow, you know that rotor copper loss is equal to S into P2. You are already studied. Copper loss is equal to slip into rotor input. So slip will be is equal to rotor copper loss divided by rotor input. That is your answer. Okay, you on the power fault diagram, you already studied that one. Rotor copper loss is equal to slip multiplied by rotor input. Okay, 1 minus S into rotor input, you will get the mechanical output, and the rotor copper loss will be equal to slip into rotor input. So what is your answer? This is a rotor copper loss divided by rotor input. Rotor copper loss divided by rotor input. This option B is the answer. And next we are using 26th question. In a double cage induction motor, the two rotor cages are in one option A star connection, option B delta connection, option C is parallel connection, option D series connection. What is a double cage induction motor? So we already discussed what is a double cage motor. Is a it's a type of a squirrel cage induction motor. So we are using when the starting torque is you need a high starting torque. Okay, that time we are using the double cage induction motor. So you can see that it is a in the rotor there is a normally one slot will be there. One slot will be containing copper bar. Copper bar will be shorted at the both end using the end ring. But here there is a two slot will be there. Okay, one is a small slot and other one is a big slot will be there. In both slots there is a copper bar will be there. The both copper bar will be short circuit at the both end and it is a connected in parallel. Okay, so both copper bar in connected in a parallel is our answer. Okay, normally so both copper bar connected in parallel, so torque will be proportional to ks into r2 divided. So you have to increase the rotor resistance, then you can increase the starting torque. So there is some explanation is there. During the starting condition, the frequency of induced EMF in the rotor is same as the supply frequency. So you know that supply frequency and rotor induced EMF will be same. Okay, and the leakage reactance of inner cage very much larger than that of outer cage. So you know that there is a one equation here, x2r leakage reactance will be s into x2. So starting condition, slip is a high value, so reactance will be high. So it is leakage reactance of inner cage is very much larger than that of outer cage. Current division in the rotor current between two cages depends on their impedance. So here there is a two copper conductor will be there, it is a connected in parallel. So the current division of rotor current between two cages depends on their impedance. Okay. Therefore, most of the starting current is flow through outer cage, which offer low impedance at the flow of current. So you know that there is some outer cage will be high resistance and low reactance time. Okay, high resistance and low reactance time is because it is like that. So the most of the current will be flow through the outer cage and it offer low impedance. So means when the starting time, okay, when the starting time, the current will be going through the outer gauge. So higher resistance outer gauge therefore develop in the high starting torque. So higher resistance will be in the outer gauge. So starting time it will take the high starting torque. At the speed of the rotor is increasing, the frequency of rotor EMF decreases. So frequency there is a one relation F2 is equal to S into F. Okay, so when the running condition, slip will be reduced. Okay, running condition, slip will be reduced and the rotor frequency will be also, slip is reduced matlab F2 will be also decrease and the frequency of the rotor EMF also decreases due to the slip. Okay, this decrease in frequency makes the leakage reactance negligible. So slip is decreasing matlab the leakage reactance will also decrease. Okay, the current division will be depends on their resistance. So outer cage having resistance, so outer cage having the higher resistance. Okay, 5-6 times of inner cage. So most of the rotor current flow through the inner cage. So that time inner cage, the most of the current will be current will be passed through the inner cage. Okay, the higher resistance of outer cage there. So the starting time higher resistance of the outer cage, therefore developing high starting torque. So finally you have to understand what on double cage induction motor there is a two cage will be there. Okay, outer and inner cage. Outer cage will be higher resistance and low reactance. So okay, inner cage low resistance and higher reactance. So then the starting time the current will be flow through the outer cage. So this is an important outer cage. It is high resistance and low reactance one. It is a inner cage will be low resistance and high reactance. So starting time the current will be flow through the high reactance, high resistance cage. That will be the outer cage. So the starting resistance is increasing. The starting torque will be increasing. Running resistance will be increasing. Starting torque will be increased. And then other one both is connected in the parallel. So our answer is that only the both are connected in the parallel. And then is an important. So when you're studying this one is an important outer cage. The starting time current will be flow through the outer cage. Outer cage high resistance and low reactance. Okay. The next question, 27. In a three-phase four-pole winding of a three-phase induction motor, in a three-phase four-pole winding of a three-phase induction motor, the space angle between two consecutive phase is okay 120-degree electrical, 120-degree mechanical, 180-degree mechanical, none of this. Okay, so when there is any motor, okay, the three-phase winding, there is a three-phase, phase one, phase two will be there. So in between the maximum of nearest phase, so phase one, phase two, phase three, so in between the angle between the phase one and phase two, it is a 180 degree. Okay, 90 to 180 is a 90 to 180. Okay, so here will be 90 to 180. What is the angle between, sorry, 120-degree difference will be there. Here 90, here 180. So 90 plus 120, what will be the answer? 90 plus 120. Okay, 90 plus 120, that is a 120. Here in between these two phase there is an angle will be 120 degree. Okay, 90, 120 plus 210 will be there. Here 210, 90, 210, 270, like that. So angle between two maximum of two near adjacent phase will be 120 degree. Any three-phase winding is angle between two consecutive winding, two nearest winding, two adjacent winding will be 120 degree electrical. Okay, so 120 degree electrical, not mechanical. So mechanical degree means it is a angle in around a point like that. So in the commonly in our electrical winding there is a electrical degree. Electrical degree means the when you're representing electrical degree matlab when the is an angle between two adjacent pole. So there is a north south pole will be there. So angle between north and adjacent north and south pole will be taken as a 180 degree. Okay, so if there is a two pole, there is a one north to south will be 180 degree. Then in the cycle the north south to north will be 180 degree, total to 360 degree. Okay, so and make electrical degree means the angle between two adjacent pole, that is a north and south, will be equal to 180 degree. Any electrical degree we are considering. So any three-phase winding, the angle between two consecutive phase will be 120 degree electrical. Option A will be the answer. Indeed, if there is an open circuit in the rotor of squirrel cage induction motor, so when the running condition, the motor become open. Okay, the motor rotor will be become open circuit. Option A, rotor will overheat, line fuse will be blow. Okay, motor will be noisy, motor will not start. Okay, there is some will be there. So when the three-phase supply is given to the stator of a three-phase induction motor, rotating stator flux will be produced, which will be induced EMF in the rotor winding according to the Faraday's law of electromagnetic induction. That you know that when your three-phase supply is giving, it will be induced EMF in the rotor winding. Okay, that is a Faraday's law of electromagnetic induction. Now, if the rotor winding is kept to open circuit, so it is an open circuit means there is no current will be flow in this winding. Okay, so it will produce the EMF in the rotor winding. If it is a open, there is a no current will be flow. Okay, As there is a no current, rotor current, there will be not any torque. There is a there is a closed circuit in the rotor. We need a closed circuit. Then only it is produce one torque. Okay, that is a basic principle of three-phase induction motor. Working principle, you know that there is a rotor. It should be short circuit. There is a short circuit. When the EMF is induced, there's close. Then current will be in the rotor circuit. That will be produce one torque. So there is a no rotor current. There will be not any torque in development. Hence the no rotation of the rotor. So what is our answer? Answer will be motor will not start. Okay, that is a not, motor will not start. Next one is in the star delta starting. Okay, you know the star delta starting is equivalent to the auto transformer starting. So there is an, you know, the star delta starter and auto transformer starter. Okay, star delta starter is equivalent to the auto transformer starting with 50% tapping, 85% tapping, 33% tapping, 52% tapping. So Mithili, tapping means when you're taking 58% means there's a 100 voltage winding. When you're taking the 58% tapping means you will get the 58 voltage. Okay. So you know that you have to go through this one in the starting time. Okay. When you're going to the star delta starter, phase, when you're connected in the star, what will phase voltage will be equal to VL by root 3. Means line voltage divided by root 3. So 1 by root 3 is equal to 0.58 into VL. That is same equation. 1 by root 3 I am changed to the value 0.58 VL. So when your phase voltage you are adjusted to the 0.58. Matlab 58% of the VL. Line voltage you are changed to the 58%. Multiply the 58% and it will become the phase voltage. So when you can change the star delta starter, okay, using a auto transformer starter, you have to give the 58% tapping. Okay, 58% tapping means is the same as will be the star delta starter. Okay, so it will same as will be the star delta starter. So our answer is 58% tapping. So you can easily convert, make you can use auto transformer as a star delta in the place of star delta starter. Means star delta starter is voltage is reduced to the 58%. And also auto transfer starter you can tap in with 58%. You can also use as a starter. Okay. Then last question, 30 question. The synchronous wattage of an induction motor means power output of the motor, rotor input, full load output, rotor losses. What is the answer? What is the answer? Synchronous watt. The synchronous watt is defined as the torque developed by the motor, such as the power input to the rotor across air gap is 1 watt while running at synchronous mode. So when you're giving the synchronous, when you're giving the 1 watt into the rotor input, okay. So okay, so when you're giving the 1 watt in the rotor input and the motor running in a synchronous speed, okay, motor running in a synchronous speed, the synchronous watt is the defined as the torque developed by the motor. So when you, what is the answer will be there? So synchronous wattage of induction motor is the rotor input, that will be in the rotor input. Synchronous wattage means that is a rotor input will be your answer. So 30 question is finished though, and then we have to discuss another 20 question. Okay, I'm going to stop this class. Okay, thank you.